Hello, I'm IndexBoss, and I'm creating a video archive about hobbies. Today we'll be giving an overview of 3D printing. This will be a very high-level overview, not covering the deeper technical aspects of getting started, or the benefits or drawbacks of specific printers or slicing software. This also isn't a business guide. I'm purely talking about hobbyist 3D printing today, so I'm not going to try and teach you how to make money with 3D prints. So in general terms, how does 3D printing work? Right? Fair question. That's one of the first things people ask me when I tell them I'm into 3D printing. It's super simple. When you're 3D printing, you're converting a digital 3D object, usually made in Blender or other 3D modeling software or CAD, and you are taking that file and having some software, those slicers I mentioned earlier, interpret that file into a series of steps or a 3D printer machine of various different types to turn into a physical object that you can hold in your hand. Really easy. There's literally those 3 steps. Get your object, get it interpreted, get it to the printer to actually print it out. At least on the overview. There's a lot of really tiny technical niche stuff you can do in between. So there are a variety of materials, techniques, and manufacturers that are in the 3D printing space, giving you a lot of ways that you can accomplish pretty much anything you want to do. A working knowledge of not only what you want to make, but also like what the conditions the object are going to be in, like is this going to be in the sun a lot, is pretty important to knowing what materials and methods you're going to be using for making your 3D printed object. Now, there are a lot, and I mean a lot, of 3D printers out there. Now, for the sake of simplicity, we're going to break them down into 2 different varieties: fused deposition modeling, FDM, and stereolithography, SLA. Now, there's other stuff out there, like more niche, like industrial stuff, like selective laser sintering, where they take a laser and shoot it at metal-containing sand, which is super cool. There's also binder jetting. We're not going to really talk about those much. They are pretty specifically like industrial manufacturing techniques, and machines, let alone the materials, can cost upwards of tens of thousands of dollars. So those aren't really going to be your like home 3D printing type deals. So FDM, fused deposition modeling, how that works, you have a machine that at its most basic level heats up plastic and has a heated nozzle deposited, fused deposition, onto a plate to build the object from the ground up. Now, stereolithography, that SLA, uses precise applications of UV light to cure resin in layers from the top down, if that makes sense. When most people think of like 3D printing, you're going to think of FDM. It's the most common type that you're going to see out there. It's the most generally accessible. It has the most materials assigned to it. It's generally easier to think of it as like the benchmark of 3D printing, right? It's the general concept. Now, between FDM and SLA, which are the 2 we're going to be talking about today, there are individual considerations as to which one is more fitting for your specific project. The first one being the size of the object you're printing. The second one being the amount of tiny details that you have on the object you're printing out. Now, FDM is generally, and I have to stress, generally, going to be better at printing out those larger, less detailed objects like statuettes, functional items, like maybe you're making a drone housing, or you're going to try and make like a case for your cell phone. Whereas SLA is going to be the go-to or creating small, high-detail objects. So if you're getting into 3D printing because you want to print out your own D&D character figurines, you're going to want SLA. Now, that doesn't mean you can't use an FDM printer to make those D&D figurines. It's entirely possible. However, you're going to need to use very specific techniques, materials, and you might want to use a higher-end printer to specifically get that to achieve the level of detail that you want. Also, there are fairly large SLA printers out there that can make fidget items and other things of larger size and structural integrity. It's going to be entirely based on like the general principles of what you're looking at. So, just to wrap that up in a bow, FDM is generally going to be your larger, lower detail. SLA is going to be your smaller, higher detail. I mentioned this earlier when we were talking about FDM. There are a wide variety of materials available out there for your hobby 3D printer. Now, I said FDM gets the majority, but there are a variety of different SLA resins that you can use. That can be used for just about as many different types of structures as you like. And primarily, you're going to use them to differentiate colors, but there's also different tolerance. I'm going to ramble. Anyway, FDM printing has the wider selection, as I mentioned. So one of the big limitations on SLA is that the resin has to be in a liquid format for most of the printers to be able to function. FDM filament is generally solids, and because it's using rolls of solid extruded plastic, you have a wider variety of materials that you can use. Some of these plastics are going to be PLA or TPU, which are two primarily prevalent types of 3D printed filaments out there nowadays. But you can also get like really fun filaments like rainbow colorations or carbon fiber or metal. Most of these are all going to be some sort of plastic binder formed around the specific material that you want inside. Or you can even get like glitter stuff. Now, when it comes to using those specialist filaments, you are going to need to use specialist printing nozzles on your FDM printer. But again, that's up for you to research. So these different types of plastics, we're not even discussing the ones that have different additives to make them cooler, just different types of plastics have different chemical structures which make them more or less usable in specific conditions. So like if you're in a moister area, if you've got more sunlight, if it's hotter, colder, if there's mechanical stress on the object, what direction is that mechanical stress located in? That is going to all influence your decision of which filaments to use. So you've got your 3D object. You've figured out what type of printer you want to use, and you picked out a few filaments. Everything's looking good. How much is all this going to get you back? Well, that's kind of the $1,000,000 question, to use a fun little turn of phrase there. Cheap FDM or SLA printers can run you anywhere from, I personally have seen them go for as low as $60, but in general, you're going to be looking in the range of $100 to $400 for a cheap printer, and that's just for the printer. The materials themselves aren't usually very expensive. I've seen rolls of filament and bottles of resin go for as low as $30 and as high as $50. On the high end, however, FDM and SLA printers can cost anywhere between $2,000 and $3,000. Certain incredibly niche usage filaments and resins can sometimes go as much as $200 a unit, which means like a bottle or a roll. Some of them are even more expensive than that. Additionally to those cost considerations, as a new hobbyist 3D printer, I do want to tell you that there are some potential risks that you need to be aware of as far as safety. In the case of FDM printing, there are filaments out there that when heated, which is the process of melting the plastic to put it down, they can off-gas some really hazardous or toxic gases that require active filtration to avoid potentially toxifying the air you're breathing. Because of this, you should ensure that your printer is located in a well-ventilated area and outfitted with active air filtration when using any of these filaments. And if you have any questions about whether or not your filament might be one of them, go to the internet, find the material safety data sheet for that type of plastic particularly. Or there might also be people online who are going to be willing to tell you that this is a hazardous material or not, but I would always refer to the official by law required guides for the material safety. On the SLA side of the house, UV cure resins used in printing in SLA are toxic. They must be safely stored when not in use. I personally had an old flame locker used for chemical storage that I stored all of my SLA filaments in. Is that required? Probably not. You're a hobbyist. You don't follow OSHA regulations as far as the storage of hazardous materials. But I would highly recommend treating it like you are in a workplace and the government might raid your house at any given time, especially if you have pets or small animals. UV cure resin, if it gets onto the skin, it can cause severe irritation, and it can also cause sensitization, which is a condition where you become more likely to develop an allergy to any particular allergen. And generally, sensitized cause allergens can be more severe than naturally occurring allergens. So you got to be really careful with that resin, okay? You should only ever handle it while wearing polyurethane gloves. I'm not saying you need to go and get surgical gloves, but you should wear gloves that do not allow liquid to transfer. So not talking about leather, not talking about cloth gloves. We are talking about a plastic glove that is going to prevent that liquid from infiltrating into your hand. You should then throw away those gloves every time when you are done. For additional safety, whenever you're done handling resin, you should rinse your hands off with at least 73% isopropyl alcohol. I personally use 90. Isopropyl alcohol can denature liquid resin. So if there's any hanging around on the cuffs of your gloves or wherever on your skin, this will help to mitigate the risk of that resin moisture hanging out on you. Also, it will prevent you from transferring it into your house. So if you do have a cat or a pet or a little one running around That isopropyl alcohol will help denature it, and then wash your hands after handling. You must also UV cure and IPA, the isopropyl alcohol, rinse all the items that you create using SLA printing. Also, if you spill any of it, there are specific instructions in the hazard data sheet, material safety data sheet. I forget what it's actually called now. Handling SLA resin just generally should always be done with extreme care and caution in mind. Finally, FDM printing. Really common, really good, really cheap. However, you are going to be heating plastic up to extremely high temperatures. It's designed to get that hot, but there's always the risk of a fire, right? You've got heating elements, you've got hot plastic, you've got all this random stuff that's getting hot. Always be cognizant that there may be a fire. So when you're printing, have a fire extinguisher on hand. And make sure that it is ready for a chemical fire, not just a standard water-based fire extinguisher. Try and find an ABC or something else that's going to be able to actually put out a potential chemical fire, because we are using plastics. Also, let's not store a bunch of flammable materials right next to your printer. Don't store a bunch of dryer lint. Don't 3D print in your laundry room. Wouldn't be smart. But overall, 3D printing is a phenomenal hobby. It can be done for very low starting investment, and it allows you to actually flex your creativity in a way that says, hey, I had this idea. I made something in my computer, and within a couple hours, I was able to hold it in my hand. It's really cool. I highly recommend you give it a look-see if you have the funds or means, whatever, to actually get into it. All right, that's today's entry for the Hobby Archive. Thanks for stopping by.